Still in example 1 and part C. I want us to just look at this very closely, that part C is asking us the probability of Z being less than negative 0.75. And if we have the normal distribution model here, and this is 0, to the left of 0, we have negative numbers considering the nature of the number line. And to the right of 0, we have positive numbers again. So our negative 0.75, assuming it's there, then we need to get the area of the region that is to the left of that, and you can see we need that region. Incidentally, the table does not give us values or areas of region under any negative value. So what do? This one should not worry anybody, because when you consider this half of the region or of the model is exactly similar to this. So by symmetry, it follows that from this edge to negative 0.75 is the same distance from this positive edge to a positive 0.75 by symmetry. And if we are looking for this area A, it is also equals to the area B. So area of A is equals to area of B by symmetry. The reason why we have done that is to avoid working entirely with negative numbers. But now our arrangement changes. Instead of now solving this kind of a problem, we are having the probability of Z being greater than 0.75, because you can see now we need that region. And at least we are now somewhere, because this means it is the whole area 1, the whole area of the model, minus the area of this region up to 0.75 to the left. We will be left with that region. 1 minus the probability of Z less than 0.75. And this one, we just go to the table and let's see what happens. Let us see what happens in the table, because we need Z, we need to have Z, and we are looking for Z less than Z. We are actually comparing the two. It is in column 2, somewhere in the middle, and the area 0.7734, 0.7734. So this is what we are interested in, because this is the area. The probability, this probability entirely gives us the area we are interested in. So 1 minus 0.7734, it gives us 0.2226, and this is now the probability of Z greater than or rather less than negative 0.75. Please note all the steps that we have followed and make an understanding of why we had to do that. Now, if you look at point or rather question part D, the part D of the question is asking us something different. Let's talk about part D there. Part D is asking us what is the probability of negative 1.18 less than z, which is less than 1.43? This is interesting because there is nothing that we need to do before we get the model. And we are talking about a region. This is 1.18 and this is positive 1.43. So we need the area of the region that is between the two, because our z is greater than this, that means to the right, and our z is less than 1.43, that means to the left. Well, what do we do? What do we do? If we calculate the area of z less than 1.43, that means we will get the area of the whole model up to there to the left. But we don't need this region, part A. We don't need it. That means we must come back and subtract it. But first of all, let us get the area of this, where the boundary is 1.43, page 201. What is that area? The table gives us the probability of 1.43 somewhere within the region is 0.9236. 0.9236. That is it. But if we give this as our answer, then we will have included this region, which is to the left of negative 1.18, and it is not required. So it is going to be this 0.9236 minus the probability of z less than negative 1.18. And at the end of the day, we have to concentrate on this part, because now we have a negative, which is this part gives us 1 minus, the way we have understood in part B, the probability of z less than 1.18. Because again, by symmetry, if we have negative 1.18, there is a negative 1.18, and this region here, call it region B, is very much equals to region C. So we are talking about now this one. So 1, the whole of this thing, minus to the left. And of course, our boundary now is 1.18, 1.18, which is somewhere within the table on page 201, which is 0.881. 0.881. So 1 minus 0.8810. What is this? 1 minus 0.88. 1 minus 0.8810 is 0.1190. Now, it is the whole of this is actually this. So our area is 0.936, 0.9236 minus 0.1190. And let us see what this gives us. Let us just see what that is going to give us. That is part 0.9236 minus 0.1190. This one is giving us 0.8046. 0.8046. Well, that is the final answer to part D, but it is important to note that it has not been realized easily. We had to understand a few things, that the area between this region, this particular boundary, to this boundary, as explained here, is eventually equals to that. So this is 0.8046. All right.